Okay, let's work on doing the shear force diagram for this beam here. So, in this particular beam, what we're going to do is we're going to label a couple points. So let's label this point here A. We're going to label this point here B, this point here C, and this point here D. Okay, now what we're going to do is we're going to start with point A, and we're going to call this shear force 1. So just to the left of this point, is there any shear force here? Just to the very left of that. If I was to put my finger on that point, no, there's none. So we're going to write shear force is 0. Now just to the right of point A, so just 1 millimeter to the right of that, what should we expect to see? So there's a force in the positive direction of 10 kilonewtons. So we're going to call that one shear force 1 prime is 10 kilonewtons. Okay. Now let's go to next point B. So put your finger right on the actual point. So just to the left of the point B, what force do we have? Only 10 kilonewtons going in the vertical direction. So let's call this, whoops, sorry, this is shear force A. Alright, shear force B, just to the left of that is 10 kilonewtons. Okay, now just to the very right of that point, I will have 10 in the positive and 8 in the negative. So let's call that shear force B prime is equal to 10 kilonewtons, take 8 kilonewtons, which is 2 kilonewtons. Okay, now let's work on the next one. So we get shear force at point C. So at point C, just to the left of that point, so you can't count this force here, we have 10 kilonewtons in the positive direction. Then we take 8 kilonewtons in the negative direction. And then you have 3 kilonewtons per meter uniformly distributed. Alright, and that is positioned through the center here. So 3 over 2 meters is 6 kilonewtons. So we get it's in a negative direction. So take 6 kilonewtons. Okay, so 3 times 2 is 6 kilonewtons. Alright, so our total shear force in this particular point is 2 take 6. We get negative 4 kilonewtons. Alright, now shear force at point C prime, so that's just to the right of this. Okay, we're going to have all these forces, plus you have the downwards force of 4 kilonewtons. So we have the 10 kilonewtons, take the 8 kilonewtons, take the 6 kilonewtons, take 4 kilonewtons, and we get negative 8 kilonewtons. Okay, let's make that a little better. Alright, finally shear force at point D. So at this point, just to the left of the point, you get 10 in the positive direction, take 8 kilonewtons, okay, take 3 kilonewtons over 2 meters, that's the same as 6 kilonewtons, take the 4 kilonewtons, so we get negative 8 kilonewtons again, okay, and shear force at point D prime, so let's include, now that's just to the right of that point. Alright, we get 10 kilonewtons, take 8 kilonewtons, take 6 kilonewtons, take 4 kilonewtons, and we got to include this one now, plus 8 kilonewtons, and you'll find that actually equals 0. Alright, so we have all our points now. Let's graph this. So let's draw a line. Okay, and this one's split up into these 3 zones, okay, 2 meters apart each. Okay, point A, B, C, D. Alright, so at just to the left of point A, we have 0. Okay, now just to the right of point A, we have 10. So we're going to now go up to 10. So let's represent 1 centimeter as 10, so right about there. Okay, now we're going to go to B, and just to the left of that we have 10 kilonewtons, so we're going to go back up to 10. Okay, and then it's going to be moving in the direction of going down towards 2 kilonewtons. So here, if you drop it down to 2 kilonewtons, it's about there. Okay, that's 2. Now we're going to go to C next. Okay, so C is -4, so we're going to go down here. That's about 4 millimeters down. Okay, and then just again, the next point on point C is -8, so we're going to go down now to about right there. And then on point D, it goes back to 0. So what does it look like? It looks like this. You're going to have, it starts like that. It drops down here to 2 kilonewtons, and then it goes to this point here. Then it drops from here to here, and then it goes back to here. So, that is our shear force diagram.